Okay. So this one here, we've got 4.8 kilogram weight. Which is sliding down a 22-degree incline. Let's try a bit better. Okay, so we've got our weight. And it's attached to a pulley, which is attached to a cylinder. And the pulley is a disc of 4.5 centimeters and mass 0.55 kilograms. And the cylinder is radius 9.4 centimeters and mass 8.6 kilograms. Okay. And it wants to know find the velocity after it has traveled a distance of 15 centimeters down the ramp. So we need to, first of all, we need to figure out what the acceleration is. So looking at the system, we've got a few free body diagrams to draw. So starting with our mass, setting this as our x and this as our y. And there's no friction, so that's okay. So we just need to worry about our mg, and that's going to be 22 degrees. And so just looking at our x direction here, we've got mg sine of 22 minus our tension is equal to our ma. Now this acceleration is going to be the acceleration of the string in the entire system. But there's our, and I'm going to call that T1. Just differentiate it everywhere here. So we've got T1, T1, T2, and T2. Okay, so now looking at the pulley, so our pulley has a T1 and a T2. First of all, so we've got some torques. So first of all, our moment of inertia for a disk is 1/2 its mass times its radius squared. So our torque 1 is going to be T1 R pulley. Now the direction is going to be by the right-hand rule. And since we've got our x-axis going this way and our y-axis going this way, this will be, I want to make sure I don't mess this up, a negative torque. And our torque 2 is going to be T2 times our distance. Again, using right-hand rule. so the torque is going to the right. Oh, sorry. So our torque 1, our RP, so this is actually a positive torque. And our torque 2, and our RP makes that a negative torque. And then our alpha is spinning clockwise, or as long as we're assuming an alpha clockwise. So then our torque 1 plus our torque 2 is our I alpha. So then we have T1 minus T2 RP is 1/2 MP IP alpha. 1/2 MP RP squared alpha. We can cancel one of these RPs and say that T1 minus T2 is 1/2 MP RP. So alpha is our acceleration over r squared, or over our r, sorry. Right, so just as omega is v over r, our alpha is a over r. And this acceleration is the same acceleration as we saw as we saw in the previous, right? Because this is going to be, our entire system is going to have this acceleration, so a over rp. And so it's 1/2 mpa. Okay. And now if we look at the hoop, so we've got this expression relating our tensions, and we've got this expression relating our tension to our acceleration. And now if we look at our hoop, now we have just one torque, just tension 2, and there's our RC. So now we have RC T2. Looking at using right-hand rule, we see this is a negative torque, so our torque is minus T2 RC. Again, having our XY axis go this way. So then this equals our I alpha. In this case, our I for a cylinder is just mcRC squared. And again, our alpha is going to be our acceleration over our RC. So then the only difference here is now our hoop is now going to be traveling in the counterclockwise direction, not the clockwise direction. So our alpha is actually our minus our acceleration over our RC. As we've reversed the direction of our travel here. So it's minus T2, RC is minus MC RC squared times the acceleration over RC. We can cancel. And so then, and this goes here, so T2 is MCA. Okay, and then from our pulley expression, we have that T1 minus T2 is 1/2 MPa, or so now we can say that T1 is 1/2 MPa plus T2, which is 1/2 MPa plus MCA. Okay? So now we have T1. And now going back to our original expression, we have mg sine of 22 degrees minus T1 is equal to m weight A. So now we can plug in our T1 and say that mg sine of 22 degrees minus mp over 2 plus mca is equal to mwa. Bringing this to the other side, we can say that mg sine of 22 degrees is equal to A times the mass of the weight plus the mass of the pulley over 2 plus the mass of the cylinder. And we could say finally that our acceleration is mg sine of 22 degrees over the mass of the weight plus the mass of the pulley over 2 plus the mass of the cylinder, or it's equal to 4.8 kilograms times 9.8 meter per second squared sine of 22 over the mass of the weight is 8.6. Mass of the pulley is 4.8. Yeah. Or mass of the cylinder, sorry, is 4. What did I do here? Mass of the cylinder, that is the mass of the weight, and the mass of the pulley is 0.55 over 2. Sorry, I kind of swapped those. And if we do this out on our calculator, we get 1.2886 meters per second squared. And now finally, we've got our acceleration. So now we're in a place to just do some basic kinematics. So xf is xi plus v naught t plus 1/2 at squared. And so then if we start from rest, v naught is 0. We're starting at 0. So then our t is our square root of 2xfa. 2xf over a. I'm just going to expand this so it's more obvious. Okay. And then our VF is VI plus AT. So dump that. So our VF is just A times square root of 2xf over A, which is the square root of 2axf. So 2 times our acceleration we just solved for. What am I doing? Meters per second squared. Times our xf, which is 0.15 meters. And this comes out to be 0.6218 meters per second. Okay. So then going through all this, we get down to the solution, which is 0.62. So that looks good. I'm gonna stop it there and say I hope you enjoyed this. If you did, please subscribe to OneClass. If you want to leave questions, please follow the comments or the links below the videos. This has been Jeff Krause for OneClass, and I hope to see you again.